Hello everyone, welcome to part 2 of the online cardiac lab. Just in case you can't see the videos in the regular, embedded in the regular PowerPoint. Thank you very much and enjoy the show.
The cardiac cycle is the sequence of events that propels blood through the heart during one complete heartbeat. Your heart beats in a continuous cycle, represented here as a clock. The cycle alternates between periods of contraction, or systole, and relaxation, or diastole, of the atria and ventricles. The timing is coordinated by the intrinsic conduction system of the heart. The sinoatrial, or SA node, initiates depolarization and systole of the atria, while the ventricles are in diastole. This is followed by depolarization of the ventricles and ventricular systole, while the atria are in diastole. Finally, between heartbeats, there is a period when the atria and ventricles are both in diastole. Contraction and relaxation of the heart chambers create pressure differences that drive blood through the heart. Blood flows from areas of high pressure to areas of low pressure. Contraction increases the pressure in a chamber, whereas relaxation lowers it. Changes in pressure within the chambers also cause the heart valves to open and close. These valves ensure that blood flows in only one direction through the heart. They prevent the backflow of blood into chambers that have recently emptied. As you'll discover, the cardiac cycle is divided into 4 phases on the basis of ventricular activity and the opening and closing of valves. These phases are called ventricular filling, isovolumetric contraction, ventricular ejection, and isovolumetric relaxation. Let's take a closer look at the timing of the events during the cardiac cycle. Representing the cardiac cycle as a clock reminds us that the events of the cycle continuously repeat. However, we will need to unwind the clock and lay it out horizontally to relate the major events of the cardiac cycle to one another. Now we can see the unwound clock depicting one cardiac cycle or heartbeat. Notice the 4 phases of the cardiac cycle. Next, we see the pattern of alternating periods. Because the cardiac cycle is a continuous process, we need to pick a starting point. We will start with ventricular filling, during which both the atria and the ventricles are in diastole. During this phase, blood from the pulmonary and systemic circuits flows passively into each atrium through the open atrioventricular valves and then into the corresponding ventricles. During this process, the semilunar valves are closed. Atrial systole finishes ventricular filling. Now let's examine the major events of ventricular filling graphically, focusing on the left side of the heart. While both the atria and the ventricles are in diastole, the ECG recording initially shows a flat line. During passive filling of the left ventricles, the volume of blood in the ventricle increases. The increase in ventricular volume slightly increases the pressure in the left ventricle. However, ventricular pressure is still much lower than aortic pressure, so the aortic valve remains closed. During a resting heart rate, more than 80% of ventricular filling occurs prior to atrial systole. Depolarization of the atria is recorded as the P wave on the ECG and precedes atrial systole. Contraction of the atria while the ventricles remain in diastole completes ventricular filling. At the end of atrial contraction, the volume of blood in the ventricles is called the end diastolic volume, or EDV. pressure in the ventricle slightly increases with the surge of blood from the contracting atrium. However, aortic pressure is still much higher than ventricular pressure, so the aortic valve remains closed. The second phase of the cardiac cycle is isovolumetric contraction. Three main events occur during isovolumetric contraction. First, atrial diastole allows blood to begin returning to the atria from the pulmonary and systemic circuits. Second, while the atria relax, ventricular systole increases pressure in the ventricles. Third, when the increasing ventricular pressure exceeds the atrial pressure, both atrioventricular valves close. However, ventricular pressure is not yet high enough to open the semilunar valves, so they remain closed. All four valves are now closed. Now let's examine the major events of isovolumetric contraction graphically, focusing on the left side of the heart. The QRS complex of the ECG is caused by depolarization of the ventricles. Ventricular depolarization initiates ventricular systole, which starts isovolumetric contraction. Ventricular contraction causes an increase in pressure that closes the mitral valve. Closing of the atrioventricular valves causes the first heart sound. During isovolumetric contraction, the aortic valve remains closed because aortic pressure is still higher than ventricular pressure. Since all of the heart valves are closed, blood cannot enter or leave the ventricle. The volume in the ventricle remains constant at the end diastolic volume, or EDV. That's why this phase is called isovolumetric contraction. With the volume in the left ventricle now constant, continued ventricular contraction causes ventricular pressure to rise rapidly, approaching the value of the decreasing aortic pressure. The third phase of the cardiac cycle is ventricular ejection. As ventricular systole continues, ventricular pressure increases, opening the semilunar valves. This event marks the beginning of ventricular ejection. The atrioventricular valves remain closed, and the atria remain in diastole. The continued contraction of the ventricles pumps blood from the ventricles into the pulmonary and systemic circuits. Now let's examine the major events of ventricular ejection graphically, focusing on the left side of the heart. Ventricular ejection begins when pressure in the left ventricle exceeds diastolic pressure, the minimum aortic pressure, opening the aortic valve. Because pressure is still lower in the atrium than the ventricle, the mitral valve remains closed. As blood is pumped into the aorta, aortic pressure closely matches ventricular pressure. Aortic pressure increases to its maximum value, the systolic pressure, and then begins to decrease. As blood is pumped from the ventricle, ventricular volume decreases. The volume of blood ejected from the left ventricle is the stroke volume. The volume of blood that remains in the ventricle after contraction is the end systolic volume, or ESV. The final phase of the cardiac cycle is isovolumetric relaxation. It begins when the ventricles enter diastole and the semilunar valves close. They close because the pressure in the aorta and pulmonary trunk is now greater than in the ventricles. The tendency for blood to flow back towards areas of lower pressure pushes the semilunar valves shut. Now that both the semilunar valves and the atrioventricular valves are closed, the ventricular volume remains constant as the ventricles relax. That's why this phase is called isovolumetric relaxation. Meanwhile, venous return from the systemic and pulmonary circuits continues to fill the atria with blood. Now let's examine the major events of isovolumetric relaxation graphically, focusing on the left side of the heart. Isovolumetric relaxation begins when the ventricles enter diastole as a result of ventricular repolarization. Therefore, the T wave of the ECG precedes isovolumetric relaxation. Isovolumetric relaxation lowers left ventricular pressure below the aortic pressure, causing the aortic valve to close. Rapid closure of both semilunar valves causes the second heart sound. At this point, both the semilunar valves and the atrioventricular valves are closed. With the ventricles relaxing and all the valves closed, there is a rapid decline in ventricular pressure. The volume in the ventricle remains at the end systolic volume, or ESV. Atrial pressure is slowly increasing due to venous return. When the pressure on the atrial side of the mitral valve exceeds that in the ventricle, the mitral valve opens. Now passive ventricular filling can begin. This starts a new cardiac cycle. Let's review what you've learned. The cardiac cycle consists of all the coordinated events that occur in the heart to pump blood during one complete heartbeat. The timing of systole and diastole depends on the electrical activity of the heart, which can be recorded by the ECG. The cardiac cycle is divided into 4 phases based on the position of the heart valves and ventricular activity. Ventricular filling occurs when the ventricles are in diastole. The atrioventricular valves are open and the semilunar valves are closed. Atrial systole completes ventricular filling near the end of this phase. Isovolumetric contraction begins as ventricular systole increases the pressure in the ventricles. The atrioventricular valves close, causing the first heart sound. Ventricular ejection occurs when the increase in ventricular pressure opens the semilunar valves and blood leaves the heart. Isovolumetric relaxation begins when the ventricles enter diastole. Ventricular pressure decreases, causing the semilunar valves to close. Closing of the semilunar valves causes the second heart sound. When the ventricular pressure becomes less than atrial pressure, the atrioventricular valves reopen. The cardiac cycle repeats itself as ventricular filling begins again.